Welcome to this video on rationalizing denominators. What does it mean to rationalize a denominator? This means that the denominator of a fraction must be a rational number. Remember, a rational number is a number that can be expressed as the ratio of two integers. This means the denominator cannot be the square root of a non-perfect square. For example, if we have 3 divided by the square root of 5, the square root of 5 is the denominator. The square root of 5 is, by definition, an irrational number. What does that mean? That means that it is a non-repeating, non-terminating decimal. The only way to express the square root of 5 exactly is simply to write the square root of 5. If you want to understand why we have this practice in mathematics of rationalizing the denominator, please watch the video on why we rationalize denominators. Example 1. Rationalize the denominator. 5 divided by the square root of 3. 5 divided by the square root of 3. So again, the problem right now is that the denominator is irrational. So what we do in order to rationalize the denominator is we multiply both numerator and denominator by the square root of 3. So take a minute and ask yourself, why do I have to multiply both the numerator and the denominator by 3? Why can't I just multiply the denominator by the square root of 3? Well, the reason is that this is an expression, not an equation. If I multiply by something other than 1, then I'm changing the value of the expression itself. So I can't do anything like that. Okay? Remember, if you think about the square root of 3 divided by the square root of 3, anything divided by itself is just 1. And remember, multiplying anything by 1 doesn't change its value. The 5 divided by the square root of 3 times 1 is still 5 times the square root of 3. So in other words, I can multiply 5 over the square root of 3 by 1 and not change its value. So let's see what happens when we do this. Well, 5 times the square root of 3 is 5 square roots of 3. What happens when we multiply the square root of 3 by itself? Well, the square root of 3 times the square root of 3, we could rewrite it like this. It's the square root of 9, which is just 3. 3 is a rational number, right? It is by itself an integer. So our final answer is 5 square roots of 3 divided by 3. And that is how you rationalize a denominator. Let's do another example. Now we have 2 times the square root of 7. Pause the video, write down what you think we should do, and then unpause it to see if you are correct. If you said that we need to multiply both numerator and denominator by the square root of 7, then you are correct. When we do this, we get 2 square roots of 7 divided by 7, and that is our final answer. How about this one? We have the square root of 5 divided by the square root of 3x. So once again, we're going to do the same thing. We're going to multiply both the numerator and the denominator by the square root of 3x. Again, this is the same as just multiplying by 1, which does not change the truth value of the expression. Okay, so the square root of 5 times the square root of 3x, we can put this all under the same denominator, under the same radical, 5 times 3x. And then, of course, the square root of 3x times the square root of 3x is just 3x. So, last but not least, we can multiply 5 times 3 and get 15. So we have the square root of 15x divided by 3x. And that's how we rationalize the denominator in that example. How about this one? 6 divided by the square root of 2x. So again, we multiply both numerator and denominator by the square root of 2x. So in the numerator, we get 6 times the square root of 2x, and in the denominator, we just get 2x. Look at this expression for a minute and see if you see anything else we can do. Do you notice that we have 6 divided by 2? Well, 6 divided by 2 is 3 over 1, or just 3. So anytime we can reduce a fraction, we must do that, or else we're really not writing our answer in simplest form, and the practical upshot of that is that you would lose points on an assignment. So our final answer, remember 6 divided by 2 is 3, so our final answer is 3 square root of 2x divided by x. X, again, is, by definition, we're going to assume that it is a rational number. All right, example 5. This one says 2 plus the square root of 3 divided by the square root of 7. So look at this and see if you can figure out what's a little bit different. Did you notice that the numerator is not a monomial, but actually has two terms, right? We have 2 plus the square root of 3. So the first thing I did, as you can see, is I put parentheses around that as a grouping symbol to help me remember that I have to multiply the whole numerator, both of those terms, by whatever I'm multiplying by. And as you probably already guessed, we're going to multiply numerator and denominator by the square root of 7. So we're going to have the square root of 7, parentheses, 2 plus the square root of 3, and of course the square root of 7 times the square root of 7 is just 7. So you might realize here our work isn't quite done. What we can do is we can distribute the square root of 7 to slightly simplify our numerator. So the square root of 7 times 2 is just 2 square roots of 7. Then we have the square root of 7 times the square root of 3, and of course this is still all over 7. Can you see anything that can be simplified? Well, I can simplify this by putting both of those numbers under the same radical. So we have 2 square roots of 7 plus the square root of 7 times 3 all over 7. And then I can just go ahead and perform that operation of multiplication. So 7 times 3 is 21. So I can rewrite this as the square root of 21. So this is my final answer. I have 2 square roots of 7 plus the square root of 21 quantity divided by 7. Example 6. So this one is a little bit different because I have not just the square root of 6, but I have 2 square roots of 6 in the denominator. Again, I have a binomial. I have two terms separated with subtraction in the numerator. So take a minute, pause this video, and make a prediction about what we need to multiply by. Well, should we multiply by the square root of 6, or should we multiply by 2 square roots of 6? One way to understand the answer to this question is to realize that 2 is not the problem. 2 is a rational number. The only thing causing the problem is the square root of 6. So we can multiply both numerator and denominator by just the square root of 6, not by 2 square roots of 6. You could multiply by 2 square roots of 6, top and bottom, but it's just going to be extra work and it's going to make you reduce at the end anyways. So the fastest way to do it is just to multiply by that radical. Again, notice that I took the extra effort of putting parentheses around the numerator. The reason I have to do this is because both square root of 3 and 9 have to be multiplied by the square root of 6. Okay, in the denominator, I have 2 times the square root of 6 times the square root of 6. In other words, I have 2 times the square root of 36. Okay, so let's go ahead and multiply. I have the square root of 6 times 3 minus 9 times the square root of 6. In the denominator, I have 2 times the square root of 36, which is just 2 times 6. Okay, we're almost there. Do you see anything else that we could do here? Just stare at this for a minute and see if you think of anything. So one thing I can do, let's look at the square root of 6 times 3. We could make it the square root of 18, right? But remember, what we really want to do is we want to pull out any perfect squares. So I always like to do the prime factorization. So let's rewrite it like this. We have the square root of 2 times 3 times 3. Do you see any pairs of numbers we can factor out? Well, we can pull out the 3. So this is going to become 3 times the square root of 2. Okay? So I'm going to replace the square root of 6 times 3. I'm going to replace that with 3 times the square root of 2 because of this work that I did right here. Do you see anything else we can do? Well, quite simply, 2 times 6 is 12. So I can replace the denominator with 12. Okay, so again, pause this video, stare at this expression, not an equation, and see if there's anything else you see. Well, do you notice that the 3 and the 9 and the 12, all of these numbers are multiples of 3. So what I can do is I can factor out a 3 in the numerator. Let's see how that would work. If I factor out a 3, I get 3 times the quantity, the square root of 2. Right, 9 divided by 3 is 3. So then I have 3 times the square root of 6. And this is all over 12. Now do you see what I need to do? Well, I have 3 divided by 12. What's 3 divided by 12? Well, that can reduce to 1 divided by 4. So what should we do? Well, our final answer, I'll put it up here so you can see it, is the square root of 2 minus 3 square roots of x, all divided by 4. Okay, notice this is in simplest terms. I have factored out everything that I can factor, and my denominator, 4, is a rational number. It is a ratio of two integers, right? 4 or 4 over 1. All right, what if we had a binomial? We had two terms separated by addition or subtraction in the denominator. So we have 3 plus the square root of 5 in the denominator. That's a little bit tricky, right? How do we get rid of the radical in the bottom? Well, what we need to do is we need to multiply by what's called a conjugate. Okay, so in general, if I have the square root of a plus b, okay, what I need to do is I need to change the sign, okay, of the radical term. Okay, so I think what I'm going to do to make this a little bit more clear is I think I'm going to rewrite this as the square root of 7 over 5 plus the square root of 3. I think that'll make it a little bit more clear. So if I have a plus the square root of b, okay, the conjugate of that expression is going to be a minus the square root of b. Okay, so let's think about what we're doing here. We are changing the sign of the radical, okay, and we are keeping the sign of the integer. Okay, the sign 5 doesn't change. So the conjugate of 5 plus the square root of 3, pause the video and take a guess. Okay, the conjugate is 5 minus the square root of 3. And of course, if we multiply the denominator by that term, we have to multiply the numerator as well. So why do we do this? Why do we multiply by the conjugate? Well, in a minute, I'm going to show you exactly why we do it. This should remind you of something. It should remind you of a difference of two squares. So remember, if you have x plus 2 times x minus 2, right, if you multiply that together, you get x squared minus 4. Right, you end up with a binomial because why? Because when you FOIL, when you expand this, you have x squared plus 2x minus 2x minus 4. And these middle terms cancel out. And that's the magic of having opposite signs here. So likewise, by having opposite signs here, I can cancel out my inner terms, meaning I can cancel out those terms that include a radical, and that is going to leave me with just an integer, which is what we want. We want a rational denominator. Okay? So let's rewrite this. We have the square root of 7 times 5 minus the square root of 3 upstairs. Okay? Then we have 5 plus the square root of 3 times the quantity 5 minus the square root of 3 in the denominator. Okay? All right, so let's go ahead and do the distributive property upstairs. So we have the square root of 7 times 5. So that's 5 times the square root of 7. Down, and then we have minus the square root of 7 times the square root of 3. Well, that's the square root of 21. Okay? Then what do we have in the bottom? Well, in the bottom, we're going to have to FOIL. Remember FOIL? So we have first, so 5 times 5 is 25. Okay, then we have our outer terms, 5 times the negative square roots of 3, so 5 minus 5 root 3. Okay, then we have our inner terms, that's plus 5 root 3. And then we have our last term, which is plus the square root of 3 times negative square roots of 3. All right, so stare at this for a minute and you'll notice, right, these inner terms are the same value and opposite signs. They are going to cancel out, which is what we wanted in the first place. We wanted to obtain something that doesn't have any more radicals in it. So we're going to have 25 plus 0, right? And then our last term, notice, is minus the square root of 3 times the square root of 3. Well, the square root of 3 times the square root of 3 is just the square root of 9, or 3. Okay, so we have 25 minus 3, which is 22. So our rational denominator is 22. So this, ladies and gentlemen, is our final answer. So before we do another example, let's practice finding the conjugate of these rational expressions. So remember, we already said if you have a plus the square root of b, the conjugate is going to be a minus the square root of b. But what if the radical was first? What if I have the square root of b plus a? Then what do? What is the conjugate? Well, remember, the idea is that the radical term, right, the square root of b, has to change the sign. The integer term has to stay the same. So this becomes the square root of b plus a. Take a minute and notice that these are equivalent expressions, aren't they? Right? You have a positive a and a positive a. Those are the same. You have a negative square root of b and a negative square root of b. Those are the same. Okay, these are also the same, right? They're just in a different order. Okay, well, what if I had a minus the square root of b? What would the conjugate be? Remember, the magic happens, the inner terms cancel out only when we have opposite signs. So the conjugate of a minus the square root of b would be a plus the square root of b. All right, well, let's make up some examples with actual numbers in them. So what if I have 2 plus the square root of 3? What is the conjugate of that expression? Well, remember, all we need to do is change the sign of the radical term. So this would become 2 minus the square root of 3. What if I had the square root of 5 minus 1? Well, remember, I need to change the sign of the radical. So right now the radical is positive. I have square root of 5 minus 1. This needs to become negative. And then the sign of the integer, negative 1, has to stay the same. Okay? What if we had negative square roots of 2 plus 1? What would the conjugate be? Again, we need to change the sign of the radical term, so it's going to become positive, and then we keep the sign of the integer term. So the conjugate of negative square roots of 2 plus 1 is just the square root of 2 plus 1. Again, the order is not important. What's important is that we're changing the sign of the radical term, and we are keeping the sign of the integer. All right, let's do maybe one more. Looks like we have room for one more. What if we have 6 minus the square root of 3? Well, again, we need to keep the sign of the integer. We need to change the sign of the radical. So the conjugate of 6 minus the square root of 3 is going to be 6 plus the square root of 3. Okay, so if this is a little bit confusing for you, I want to encourage you to practice the skill of finding the conjugate before you do more examples where you multiply by the conjugate. All right, let's do one more example here. So here we have two binomials. We have the square root of 2 plus 3, right? Ooh, this is interesting. In the denominator, we haven't seen something like this before. We have the square root of 5 minus the square root of 7. So what are we going to do here? Are we going to change the sign of both radicals? What do you think? Pause the video and write down your guess. Okay, well, what we're going to try to do, and we'll see if this works, is we're going to actually just multiply by the square root of 5 plus the square root of 7. And we're going to do that upstairs and downstairs in the numerator and the denominator. Okay, so you can probably sort of realize that we're going to have two different FOIL problems. So I moved all of that expression up to the top so that we have more room. So let's just FOIL the numerator. So anytime you're doing work that you're going to turn, it's always good to label your work so it's easier to grade and easier to follow. So the numerator is the square root of 2 plus 3 times the square root of 5 plus the square root of 7. Okay, so let's FOIL. So we have our first terms. So we have the square root of 2 times the square root of 5. Okay. Then we have our outer terms. So we have plus the square root of 2 times the square root of 7. Then we have our inner terms, so plus 3 root 5. And then we have our last terms, which are 3 root 7. Okay, so you probably realize we can change this to the square root of 10 plus the square root of 14 plus 3 square roots of 5 plus 3 square roots of 7. And that whole thing is going to be our numerator. Okay, now we need to find our denominator. And if we did this correctly, and if we wrote our complex conjugate correctly, remember, by multiplying the square root of 5 minus the square root of 7 times the square root of 5 plus the square root of 7, remember, our goal is to get a rational number. If we don't, then this is not the correct conjugate. So let's do the first term. So we have the square root of 5 times the square root of 5. Square root of 5 times the square root of 5. Okay, then we have our outer terms. So we have plus the square root of 5 times the square root of 7. Then we have our inner terms. We have minus root 5 minus root 7. Okay, then we have our last terms, which is minus root 7 times root 7. All right, so let's see what happens. Notice that this does look correct. These inner terms are going to cancel out. They're the same value and opposite signs. All right, well, what's the square root of 5 times the square root of 5? Well, that's just 5, isn't it? And the square root of 7 times the square root of 7 is just 7. So we have 5 minus 7, which is negative 2. So we did correctly identify the conjugate, right? So now all we have to do is we have to put the numerator and the denominator all together into a single fraction. So let's go ahead and do that. So we're going to have the square root of 10 plus the square root of 14 plus 3 square roots of 5 plus 3 square roots of 7, and this whole thing is divided by negative 2. So this is going to be our final answer.